For this problem, we're given a function, a rational function, f of x, and we are asked to find many things, and if any of the answers to those questions come out where they do not exist, we are to write D and E. The first question I'm going to tackle is what is the vertical intercept? A vertical intercept is the place where the graph crosses the vertical axis, that's the y-axis, and looking right here, it looks like somewhere around -4, the graph has a vertical intercept. But what's true about all vertical intercepts is that point would have an x value of 0. If you're on the y-axis, your input is 0. I'm guessing that it's -4, but to find out, what you could do is write your function down, and where I see the letter x, I'm just going to leave a blank space because I'm about ready to replace that with the number 0. So vertical intercept, plug 0 in for x. That would go here, here, and here. And you could simplify this down. 3 times 0 is 0. And then 0 subtract 4 would be -4. And then 1 minus 0 is simply 1. And -4 divided by 1 is -4. And if you took the time to graph this, you would see that it certainly looks like it crosses at 0, -4. The horizontal intercept is the reverse. It's where the graph crosses the horizontal axis, which is the x-axis. And this being 0 and this being 5, it looks like somewhere around between 1 and 2, maybe just to the right of 1, I would have myself a horizontal intercept. And what's true about a horizontal intercept is, I'm not sure what the x value is, I got to find that out, but what's always true is that your height above the x-axis is 0, right? The y-coordinate of that point is 0. So I would take my output variable, which is f of x, and replace it with 0 this time. And there is a shortcut to this, but let me not just jump to the shortcut. Let me say that this time we're going to take the output variable there and replace it with 0. And I'm going to be solving this equation for x, and that would give me the horizontal intercept. And one way to do this is to multiply both sides by 1 minus x. Because this is being divided by the quantity 1 minus x, if I multiply by 1 minus x, it will simplify out. But what you do to one side of the equation, you must do to the other. Now, some faculty might call this cross multiplication, and that works too. But either way, you get this to simplify out to be 1. Anything divided by itself is 1. So I'd have 3x minus 4 on one side of the equation. And on the other side, since 0 times anything is 0, you're left with 0 there. So notice it really didn't matter what my denominator was, that when I multiplied it by 0, because anything times 0 is 0, it basically went away. What I'm left with is just my numerator set equal to 0. So you might have a teacher that says if you want to find the horizontal intercept, it's okay, provided you have a rational function of this form, to simply set the numerator equal to 0 and solve. So doing so would be just as simple as adding 4 to both sides, and you'd get 0 plus 4, or 4 on this side. Here, -4 plus 4 simplify out to give you plus 0. And then since the 3 is being multiplied, I would divide both sides by 3. 3 divided by 3 is 1, so this would be 1 times x, or just x. And I would get 4/3, which is about 1.333, which looks like that would be plausible, given that this is 0 and that is 5. That looks like it very well could be 1.3333. So here we got that 4/3 was the input to give you an output of 0. That was the horizontal intercept. Now the domain of the equation would be what kind of x values you can plug in the equation and expect to get a valid output. So it turns out that there's usually two things that you worry about when you look at an equation. You don't want to have division by 0. If you divide by 0 in mathematics, there's no meaningful way to define that, so we call that bad. So we want to exclude any x values for which that bad situation would happen. So you may notice just looking at the graph, you usually just look how far left and how far right the graph goes, and it goes infinitely far to the left and goes infinitely far to the right, but there is one x value that the curve does not take on, and that's this one right here, and that's what we're going to find. What is that x value that for some reason when you plug that x value in, there's no y value, something bad happens. So to find the domain, what I'm going to do is I'm going to write my denominator here, 1 minus x, and I want to find the x values so that my denominator is equal to 0. So if you want, I'm finding x so that my denominator is 0. And by finding that x value that makes my denominator 0, I'm going to exclude that from the domain. It's the one bad x value, if you will. So there's my denominator. I'm going to find out the x value that makes that 0. All I'd have to do is add x to the other side. You'd have x plus 0 on the right-hand side, which is x. On the left-hand side, you'd have 1. And then the minus x and plus x make 0. I won't write that. So if someone were to replace x with the number 1, they would get 1 minus 1 in the denominator, which is 0. And in mathematics, there's no meaningful way to define that. So we're going to say that the domain is basically all real numbers except for x equals 1. So basically we're saying you can plug in any x value. Notice the graph basically goes to the left forever and to the right forever. It's everything. It's all real numbers. And then we're going to exclude, because there's really infinitely many that we have to include. It's easier just to exclude the one that's bad. So all real numbers except x equals 1. So the issue with this, and this is fine, is that we were supposed to write our answer in inequality notation and interval notation. So to write it in inequality notation, this would be simply that x has to be less than 1, can't be 1, or it could be x is bigger than 1. And by writing it that way, you're basically saying anything but 1. So that would be inequality notation here. So interval notation, what you'd have to say is that the graph goes to the left forever to negative infinity up until you hit the number 1, and we have to put a parenthesis there to exclude the number 1, because remember 1 is an x value that we do not know how to define the corresponding output. And then the other part of the interval notation would be from 1 to infinity. So from x equals 1 there to the right, it goes forever to the right. So we're going to denote that as positive infinity. And the notation that you're supposed to use in set notation is if you have two different intervals, you combine them using a union symbol. So that's the answer to this part. Moving on to the part where I determine the equation of the vertical asymptote, I basically already did that. The way to find a vertical asymptote is to find x values that make the denominator 0. We got that x equals 1 was the bad place. So that's not only just the x value that makes the output undefined, it's also the equation of a vertical line. So try to remember that when you write x equals 1, you're not just given an x value that makes things go bad, so to speak. You're actually writing down the equation of a vertical line. If your teacher said, please graph the line x equals 1, you were to graph a vertical line right up and down that passes through the number 1 on the graph. So we typically dot this when we graph rational functions, and we dot it so that we know that there actually is no y value there, right? These aren't points on the graph. It's just a reference line to say that your graph gets infinitely close to that line x equals 1. And I can't write the word line down enough, because it's difficult to know if students realize when they write x equals 1 that they are indeed writing the equation for a vertical line. So we got x equals 1 is the equation for the line, x equals 1. And I'll move on to determining the equation of the horizontal asymptote. So a horizontal asymptote, I want the equation of a horizontal line, which is always y equals a number. And I'm not going to go through all cases. I'm simply going to go through the case necessary to do this one. So for this problem, you would find the horizontal asymptote by comparing the degree of the expression in the numerator, which is 1, to the degree of the expression in the denominator, which is 1. Remember, the degree of a polynomial is simply its highest exponent. So this is degree 1. And this one here has a highest exponent of 1, so it is also degree 1. So the rule for horizontal asymptotes is that if the degrees are the same, that you will get a horizontal asymptote. So it'll be the equation of a horizontal line, which is always written y equals some number. And that equation would be found in this case by looking at the leading coefficient. So the leading coefficient is defined to be the number in front of the variable with the highest exponent. Well, we already said this is the x value with the highest exponent, so that coefficient in front is 3. Down here you have to be careful because they wrote things in ascending order rather than descending order. So the number in front of my variable with the highest exponent would actually be -1 there. So my leading coefficient is -1. So you would form that ratio, 3 divided by -1. You could simplify that down. That would be y equals -3. Or since we're not using y, we're using function notation, you may want to write that as f of x equals 3. It would mean the same thing, excuse me, negative 3. So what that means is, and I'm not sure you can see it, but this is negative 5 here on the graph. So what we're saying is for very, very large x values to the right and to the left, your y values level off to a certain height. In fact, it looks like the graph is horizontal here, and it looks horizontal there. Well, all we're asking is, what is that line that it's approaching? So this time, you get a reference line that is horizontal, and we want to know what that cuts through. So the graph basically looks like the line y equals 3, way to the right and way to the left, and it's basically all the question is asking for. So we got y equals negative 3 as the equation for the line that the function approaches as it goes to the right and to the left forever. So remember, this is the equation for the line y equals negative 3. It's a horizontal line. The last two parts are more just arithmetic. It says determine f of 5. That would mean that your input is 5 and we're looking for that corresponding output. So you could estimate it on the graph. In fact, it's difficult to tell, but this right here is negative 5. So I don't know, what does it look like? It looks like if you plugged in 5, which is right here, you would get roughly, I don't know, negative 2.5 or negative 3, I'm thinking. You'd simply have to replace x with 5 here to get that. So doing so would be f of 5 equals 3 times 5, subtract 4, and then in the denominator I'd replace this x with 5, and simplifying I would get that 3 times 5 is 15, 15 minus 4 is 11, and 1 subtract 5 is negative 4, so I get that the answer is f of 5 is negative 11 fourths. Let me see, 4 goes into 11 2 times, that would give you 8, with 3 left over. So if you want, as a mixed fraction, my answer is that f of 5 is negative 2 3/4, which is negative 2.75. Remember, as a guess, I said negative 3 roughly. So let me write down that we got that f of 5 turned out to be a negative 11 fourths. The next problem is similar. This time, they're asking when the output f of x is 3. So this time I'm going to be replacing f of x with 3 and solving for x. And again, you could look at the graph and you could get an estimate, and you could say, when is the y value about 3? So here we are at 5, here's 0, 3 is right here, so here would be the point whose output, f of x, would be 3, and our job is to find the x value. So it's going to be a little bit bigger than 1. I can't tell from the graph exactly what it is. Is it 1.2? I don't know. We have to solve this equation to find out. So what I'm going to do is I'm going to multiply both sides of the equation by 1 minus x. And you can think of this as we're cross multiplying, that works too. Or you can just think of it as, because I have a division by 1 minus x on this side, if I were to multiply by 1 minus x on both sides, this would simplify out, and I would be left with just 3x minus 4 on the right-hand side. On the left-hand side, at least let me write the 3 to the left of the 1 minus x, because that's how you typically would see it. So now I'm going to distribute the 3. I get 3 times 1 is 3. I get 3 times negative x is negative 3x. And over here I have my 3x minus 4. To solve this, I'm going to choose to add 3x to both sides. And what I'm going to get when I do that is this will simplify out here. I'll be left with 3. Over here, 3x plus 3x is 6x, but you still have subtract 4. To continue solving, I'm going to have to add 4. So doing so, I'm going to get negative 4 plus 4 simplify out here. I'm going to be left with 6x on the right-hand side, and on the left-hand side, I get 3 plus 4 is 7. And since the 6 is being multiplied, I'm going to divide by 6 on both sides. 6 divided by 6 is 1, so you'd be left with 1 times x, or just x over here, and 7/6 over here. Remember that I said that the answer is about 1, maybe a little bigger, so we got 1 and 1/6. So this looks pretty reasonable given the graph there. So my answer to this one is, when it said determine x, is that to get an output of 3, you'd have to have an input of x equals 7 divided by 6, or 7/6.